Welcome to this explainer. Look, if you're a focused learner looking to truly master the art of debugging, you are in exactly the right place today. We're setting the stage for a really fascinating investigation into both the deep psychology and the everyday hands-on practice of software development. We're going to look closely at what it actually takes to build reliable software and honestly, more importantly, how we mentally process the hurdles we inevitably hit along the way. So get ready to completely reevaluate everything you thought you knew about broken code.
Let's start with a really honest question. Do coding mistakes make you feel, incompetent? You know the feeling. You compile your work and boom, the screen suddenly lights up with angry red text. What's your immediate emotional reaction? The psychological pain of making a coding mistake is profoundly real. It's incredibly frustrating, and it's just so easy to take that error as a direct reflection of your own skill level. It can literally feel like a personal failure. But today, we're going to use a really fun detective metaphor to validate that frustration you're feeling, and then we're going to completely upend it. We're going to see exactly why that feeling of incompetence is a total trap.
Okay, let's dive right into Section 1, the developer's detective work, where we start solving the mystery in the code. I really want you to stop looking at your code as just a rigid set of instructions that you either got right or got wrong. Instead, frame the code as the scene of a crime. There's a mystery here. Something isn't acting the way it should, and you, the developer, are the lead sleuth. Your job isn't to be absolutely perfect from the start. Your job is to track down the culprit, the bug. Our source material is incredibly clear on this point. Finding errors is not some tedious chore or a punishment for bad typing. No way. Debugging is highly engaging investigative work. Just like a detective piecing together a timeline, finding a bug requires patience, and it demands a strict logical approach. You have to trace the execution, gather your clues, and logically deduce exactly where the program went off the rails. It completely transforms the act of coding from passive typing into this active, intellectual pursuit. To really understand how to apply this, let's meet our guide in Section 2, the Tim Corey philosophy. Meet your chief detective.
So, Tim Corey is a renowned C# educator, and our sources highlight his uniquely effective approach to systematic program design. He doesn't just teach syntax, he teaches the reality of being a developer. And as a seasoned chief detective in the world of code, Corey intentionally embraces flaws. He sees them not as embarrassing accidents to be hidden away, but as absolutely critical parts of the development process. His core teaching brilliantly illustrates this. Thinking like a programmer actually means embracing mistakes. In fact, Corey does something highly unusual and highly effective in his educational videos. He intentionally leaves real-world errors in his presentations. Instead of editing out his missteps to look perfectly polished, like everyone else does, he keeps them in. He does this to show his students the authentic, messy process of fixing them. He models the exact behavior a developer needs, encountering a bug, totally not panicking, and systematically hunting it down.
This brings us right to Section 3, Errors Are Not Incompetence, where we are redefining the bug.
Now, what's really interesting about this slide is how we transition from the narrative of the detective into the underlying psychology of the coder. If we're going to adopt the Tim Corey philosophy, we have to completely shift our perspective on what an error actually represents in our daily workflow. Notice the stark contrast here. Look at the old view. Errors equal incompetence. That is the exact mindset that causes panic and imposter syndrome. But look at the Corey view. Errors equal the fundamental creation process. Encountering errors is not a sign that you're bad at your job. Encountering errors means you're actually doing the job. You're building something complex, and the flaws you uncover are literally just the stepping stones to a finished, working product. It's a massive, game-changing psychological shift from feeling like a failure to realizing, hey, I'm just engaged in the standard process of creating software.
And this powerful reframing is absolutely essential. Because when you stop fearing errors, you can actually start using them. The texts emphasize that developers must transform technical hurdles into learning opportunities. Every single time your code breaks, it is directly pointing out an edge case you didn't consider, a logic gap you missed, or maybe a quirk of the language you just didn't fully understand yet. It's a direct opportunity to deepen your skills. Those frustrating roadblocks, they simply become guideposts telling you exactly what you need to learn next.
Let's move to Section 4 and see how this builds into the investigative toolkit. Practical tools for the code sleuth.
All right, so we've established that we need to be detectives, and we've got the right mindset. But what practical tools does the code sleuth actually use to solve the case? Well, our sources outline two fundamental steps for this detective work. Step 1, analyze error messages. The source material strongly emphasizes teaching students how to actually read these messages. An error message isn't just the computer yelling at you, right? It's a witness statement. It's giving you a line number, an exception type, and a stack trace. Listen to the witness. Step 2, Implement rigorous testing. Testing is how you set traps for bugs. By using rigorous testing, you can proactively find those hidden problems in your code way before they ever make it to production. These two techniques combined are exactly how you sleuth out the issues methodically.
Which brings us to Section 5, Building a Systematic Mindset, our ultimate resolution.
So, the crucial point is this. When you combine the psychological reframing we discussed, accepting that errors are just the creation process, with the practical toolkit of analyzing messages and rigorous testing, you forge a completely new approach to programming. A systematic mindset is defined as the practice of identifying and resolving flaws as a core professional skill. Notice that phrasing, a core professional skill. Debugging isn't some annoying interruption to your job. It literally is the job. Cultivating this systematic mindset is what turns everyday technical hurdles into true professional mastery. It's the whole shebang. It is what separates a frustrated typist from a master software detective.
We've covered the psychology, the philosophy of Tim Corey, and the investigative tools you need to succeed. So I want to leave you with this final, provocative thought. Knowing what you know now about the fundamental creation process, how will you approach your very next broken line of code? Will you see it as a reflection of incompetence? Or will you grab your magnifying glass, enthusiastically embrace the mistake, and start your investigation? The mystery is waiting for you. Thanks so much for joining me on this explainer, and happy sleuthing.